Welcome friends. Myself Professor Piyush Joshi working as an assistant professor in Chemical Engineering Department of KK Wagh Institute of Engineering Education and Research Nasik. Welcome you all. In this video we will be discussing characterization of nanomaterials using different characterization techniques. First of all, introduction. The characterization refers to the study of materials, features such as its composition, structure, and various properties like physical, electrical, or magnetic properties, etc. The nanomaterials dispersed in the form of colloids in solution, particles, it may be dry powder or thin film deposited on any substrate, are characterized by various techniques. Although the techniques to be used would depend upon the type of material and the information required to by any person. Usually, one may interested in first knowing the size, crystalline type, composition, thermal, chemical state, and different properties like optical properties or magnetic properties, etc. So for this purpose, the characterization would useful for the researchers. Let us now discuss the different microscopes available for characterization. If we consider the optical microscope include the simple compound microscope, stereoscopic microscope, and confocal microscope. The second method possible in microscope is by the use of X-rays. In X-ray, we can use the STXM, TXM, and XPEEM. So these are the different microscopes in which we can use the X-ray. The third type of microscope, we can use the electron. This electron microscope may be the TEM, that is transmission electron microscope. It may be SEM, scanning electron microscope. It may be STEM and REM. Next is the different probes can be used, in which again the classification is STM, EC, STM, MFM, CFM, EFM, AFM, and CFM, etc. The next microscope is depending upon the acoustic properties, and that may include the SAM and CSAM. So these are the different microscopes can be possible. If we consider the different microscope, it is again mentioned here, the full forms are mentioned here. The optical microscope, confocal microscope, electron microscope, we are interested in scanning electron microscope and transmission electron microscope, SEM and TEM respectively. The next is the scanning probe microscope, that is SPM. It includes or the further they may be classified as scanning tunneling microscope, atomic force microscope, that is AFM. The first one, scanning tunneling microscope, is also called as STM. Atomic force microscope, it also called as AFM. Next is the scanning near field optical microscope, it abbreviated as SNOM. Next is the diffraction techniques we can use for characterization. It includes the X-ray diffraction. It is abbreviated as XRD. Next is the spectroscopic methods for the characterization. So this include ultraviolet visible NIR spectrometer. So it is infrared spectrometer. Next is the infrared, that is IR spectroscopy. Next is dispersive infrared spectrometer. Next is the Fourier transform infrared spectrometer. So it is also called as FTIR spectrometer. The another spectroscopy that we can use for characterization is Raman spectroscopy. The next one is the optical. In optical, we can use the ultraviolet, visible and near infrared, that is UV, VIS and NIR spectrometer, as we already mentioned. So optical absorption spectrometer that we can also use. The next measure or characterization method is magnetic measurement. It can be done by vibrating sample magnetometer. It is also abbreviated as VSM, vibrating sample magnetometer. And last one is the mechanical measurements. If we see the different characterization methods and their usage, I mentioned in this table. On the left hand side, the acronym, the second column include the full form of that particular method, and third column include the use of that particular characterization method. Let us discuss one by one. The first acronym is ACM. The full form of ACM is Scanning Electron Microscope. We can use the scanning electron microscope for imaging, topology and morphological observations of the nanoparticles. Next acronym is TEM. TEM. So TEM stands for Transmission Electron Microscope. The transmission electron microscope can be used for imaging purpose as well as the particle size and shape analysis of different nanoparticles. Next one is the AFM. AFM stands for Atomic Force Microscopy, and we can use the atomic force microscopy for imaging topological characteristic and surface structure of nanoparticles can be observed using AFM. Next is the STM. STM stands for Scanning Tunneling Microscopy. The use of scanning tunneling microscopy is for topology, imaging and surface structure of nanoparticles can be characterized. Next method is AAS. AAS stands for Atomic Absorption Spectroscopy, and this is generally used for the chemical analysis or chemical composition analysis of the nanoparticles. And the last one mentioned in this table is XRD. XRD stands for X-ray diffraction, and the X-ray diffraction characterization method can be used for the crystal structure observation or crystal structure observation of the nanoparticles. Let us discuss the microscopy first. What is microscopy? The microscopy includes observation and examination of minute objects which will provide a magnified image of an object not visible to the naked eyes. The microscope is usually have three main types. They are as follows. The first one is the optical microscopy. Second is the electron microscopy. And next one is the scanning probe microscopy. It is generally abbreviated as SPM, scanning probe microscopy. Let us discuss the microscope first. Low dimensional materials such as quantum dots, quantum wires, quantum wells, self-assembled materials, interaction of small molecules with the surfaces of substrate, multilayers, etc. need special microscope as follows. The different microscopes used for such characterization may be transmission electron microscope, that is TEM. The next one is the scanning tunneling microscope, that is STM. The next microscope is the atomic force microscope, that is abbreviated as AFM. The next one is we can use is the scanning near field optical microscope. So it abbreviated as SNOM. However, in many instances, one may inspect the sample, especially thin films, with an optical microscope to check the quality of samples like presence of cracks, agglomeration at large scale, etc. Therefore, we shall begin with a simple optical microscope. Here, we define some common terminologies that can be used in microscopy analysis work and then discuss the other microscopes. So, if we see the scope of microscope, we can human eye, the naked human eye can see the things that can be in the range of 1 mm to 10 meter. So 10 meter is human height. Then if we go down to 1 meter, length of some nerve and muscle cells. 0.1 meter is the chicken egg. 1 centimeter frog egg. And if we go down below 1 mm, so we can use the light microscope for the minute appearance observations. If we go down to 100 micrometer, the eukaryotic cells are present in this particular range of 10 micrometer to 100 micrometer. If we go down from 10 micrometer to 1 micrometer, the nucleus of cells, most of the bacteria and mitochondria can be observed under the light microscope in this range of 1 micrometer to 10 micrometer. If we again go down from micrometer to nanometer, we have to use the electron microscope as shown in this figure. We can observe the 100 nanometer. If we consider example, it may be mycoplasma or many viruses are in this range of 100 nanometers. If we consider the range 10 nanometer to 100 nanometer, the ribosomes, viruses and mycoplasma can be observed under the electron microscopes. Again, if we go down on the nanoscale from ranging from 1 nanometer to 10 nanometer, we are having the lipid molecules and protein molecules which can be observed by using the electron microscopes. Further, if we go down to the atom level, that is 0.1 nanometer to 1 nanometer, it includes the atoms of different substances and small molecules. So these can also be observed using the electron microscope. So this is the different characterization or microscopic methods that can be used for various purposes. Let us now discuss electron microscope. Electron microscopes are scientific instruments that use a beam of highly energetic electrons to examine the objects on a heavy fine scale, which yield the following information. It can take the information of topography, the surface features of an object include hardness, reflectivity, that include under the topographical information of the material or the nanoparticles. Second information is regarding morphology. Morphology include the shape and size of the particles, different characteristics like ductility, strength and reactivity are also considered under this morphology. The third important information we can obtain using the electron microscope is the composition. The elements and the compounds that the object is composed of and the relative amounts of them, that is the composition. We can find out in the composition. The last one is the crystallographic information. So we can count how how the atoms are arranged in the object, we can easily identify using the electron microscopy. So these are the four different informations that may be important in the characterization of the nanoparticles. Topography, morphology, composition, and crystallographic information can be possible. If we compare the light microscope versus electron microscope, the simple light microscope, we are using the source of illumination as light. Light by any means, as shown here, we can use the lamp as a source of illumination. Then we condense the we use the condenser lens to condense the light so as to focus on the specimen to be observed. After focusing on the specimen, it goes to the objective lens, and finally through projection lens we can observe with our eyes. On the other hand, if we consider the electron microscope, the source of illumination here is the electron beam. We can use the source of electron beam as a medium for observation purpose. The electron beam through condenser lens is focused by means of the focusing lens, and the condenser lens on the specimen, and some of the electrons may be transmitted, some of the electrons may be scattered. As I mentioned here, it is the incident electron, the main arrow shown as I am highlighting out here is the incident electron. The some electrons may be backscattered to the in electron microscopy. Some may cause the production of secondary electrons, and some may be producing the specific X-rays. Whereas if we consider some electrons may be diffracted from the specimen, and some electrons can be passed through, that are called as the transmitted electrons. So depending on the type of electron beam we are observing, the electron microscopy is further called as scanning electron microscopy, which is usually based on the backscattered and secondary electron, and TEM, that is the transmission electron microscope, we detect the transmitted electrons from the specimen. So this is the basic difference between the scanning electron microscope and transmission electron microscope. If we consider the scanning electron microscope, the principle here we are using here, same images the sample surface by scanning with a high energy beam of electrons, as we already discussed in previous slide, under high vacuum. Here the high vacuum is important so that there should be no contaminant should be entered in the system, and that is why the same is operated under high vacuum conditions. The electrons interact with the atoms that make up the sample, producing signals that contain information about the surface topography, composition, electrical conductivity, etc. The procedure used in scanning electron microscope is samples are coated with electrically conductive materials like gold, platinum, osmium, and graphite, etc. This coating prevents a static electric charge accumulation on the specimen during the electron irradiation. This electron irradiation will cause the creation of static electric charge, and to protect the specimen from the static charge, we coat it with the electrically conductive material. If we consider the scanning electron microscope, it will having the schematic like this. If we consider and compare the electron microscope with the light microscope, the many of the components, basic components are similar. In a light microscope, we use the light as a source of illumination, whereas in electron microscope, the electron microscope uses an electron gun to produce the electron as shown in this figure. Figure on the left and right, it's same. It is the electron gun that is the source of electron. An electron microscope has many of same component as light microscope. The electromagnetic lenses are used to focus the electrons, and the detector, which is sensitive to the electrons instead of visible light, can be used. Electrons can interact with the sample in a number of ways, as we already discussed. That is the backscattered secondary electrons that we can detect in the electron microscope. When an electron beam strikes on the specimen, some of the electrons are absorbed, other electrons are backscattered as shown here, that is secondary electron detector, and some sample electrons can be ejected as secondary electron as shown here, secondary electron detector. If the number of electrons that strike the sample is not equal to the number of electrons that leave the sample, then the sample will build up a charge. This is generally called as charging, and it negatively affects the quality of the resulting image. In order to prevent charging, many scanning electron microscopes are coated with thin layer of metal, as I already mentioned. Scanning electron microscope can typically image features as small as 1 to 2 nanometers and as large as 1 or 2 millimeters samples. The backscattered scanning electron microscope image show fewer surface feature than the secondary electron images. Many electron microscopes have both secondary and backscattered electron detectors, and acquiring both images on the same sample can illustrate the differences between them. In a typical scanning electron microscope, vacuum is required because the electrons that we use for imaging will scatter off gas molecules and prevent us from focusing the electron beam on the specimen. As a result, we can only image dry sample in a typical scanning electron microscope. If we want to look or observe the wet sample, we need to dry them first and then use it in a scanning electron microscope. This will cause the distortion of their shape. So this is the typical working of the scanning electron microscope. Alternative to coating is to increase the bulk conductivity by the impregnation with osmium can be possible. Size range, as I already mentioned, we can observe 1 to 2 nanometer easily using the scanning electron microscope. If we consider the disadvantages, the first disadvantage of scanning electron microscope is the sample must be dry before it used in the scanning electron microscope. The second disadvantage, the coating agent may change the morphology and the size of the particles to be characterized. And third, it provides only two-dimensional projection of the specimen. Next is the transmission electron microscope. As I already mentioned, depending upon the incident of the difference in the incident electron when it refer or focus on the specimen, some of the electrons are transmitted, some are backscattered, some are produced the secondary electrons from the specimen itself, and some are produced some specific X-rays. So depending upon the detection method, if we are using the secondary electron and backscattered electron, the electron microscopy is generally called as scanning electron microscopy. If we are using the transmitted electron from the specimen, the microscopy is called as the transmission electron microscopy. So we have already seen the light microscopes are limited by the physics of light to 50x, 500x or 1000x magnification and a resolution of 0.2 micrometers. In early 30s, there was a scientific desire to see the fine details of the interior structure of some organic cells such as the nucleus, mitochondria, or study of some bacteria and viruses. This particular need required 1000 times magnification, which was just not possible using the light microscope. And that is the need of time, and that will lead to the invention of the transmission electron microscope. So if we compare light microscope with the electron microscope, we already seen we use the light source for light microscopy, whereas in electron microscopy we use the electron gun as an electron source. Then through this electron beam is passed through some condenser lenses, and then it follows on it explores to the specimen, and electrons are transmitted through the specimen, and then it is called as transmission electron microscopy. Whereas if the electrons are backscattered and it produces the secondary and backscattered electron, if we are detecting those, it is generally the scanning electron microscopy. So that is the basic difference between the transmission electron microscopy and scanning electron microscopy. Electron microscopy uses the magnetic lens, large depth of field, higher magnification and better resolution. It also operates under high vacuum. The transmission electron microscope uses a wide beam of electron passing through a thin sliced specimen to form an image. This microscope is analogous to a standard upright or inverted light microscope. Electrons are scattered when they pass through the thin section of the specimen. The transmitted electrons, those that do not scatter, are used to produce the image, and that is why it is called as the transmission electron microscope. The denser regions in the specimen scatter more electrons and appear darker. The ultra-thin section of the specimen, light passes through the specimen, then an electromagnetic lens to a screen or film can be possible. The specimens may be stained with heavy metal salts for better resolutions. I hope this information will help you a lot in characterization of nanoparticles. Thank you. If you like this video, please share and subscribe my channel for new updates. Thank you.